Hi guys, today we are going to look at histograms. As you can see on the page, I've got two different diagrams, very similar but also quite different. On the left you can see I have got 4 bars. I've got the height on the x-axis and on my y-axis I've got the frequency. Now on the graph on the right hand side I have got again 4 bars. I've got the height on the x-axis, however on the y-axis this time I have got frequency density. Now this is the main difference between a bar chart and a histogram. So first difference that I've just identified is that for histogram the y-axis shows frequency density rather than frequency, and also apart from my vertical lines being slightly wonky because I did it on plain paper rather than on squared paper, you can see that the width of the bars are all different, whereas on a bar chart they are all uniform, and that's really important. The width of the bar on a histogram we call the class interval. So I've just written out a few bits of key information that you might want to write down to help you in your notes, written it down just to try and help speed up the video for you. So 3 pieces of information about histograms. Class intervals are not equal, so as I've just mentioned, the class interval is the width of the bar that you will be drawing on your histogram. The y-axis shows frequency density, which I've shown you here. And finally, and I think this is probably one of the most important bits about histograms, apart from the frequency density and the different width bars, is the fact that the area of each of these bars will represent the frequency for whatever group the data is showing, and I'll show you that in some examples. Before I show you the examples, there are 2 formulae that you need to learn. They're just a rearrangement of each other. So I've got frequency density times class width is the frequency. Now this links to this bullet point here that I've just mentioned about. The area of the bar represents the frequency. Now if I do the frequency density, which is the height of the bar, and I multiply it by the class width, which is the base of the bar, base times height gets me the area, which is the frequency. So that's that point there. Now to get this second formula, all I have done is basically divide both sides by class width to leave me with frequency density is equal to my frequency divided by or over the class width. So what I'm going to do now is I'm going to show you 5 different exam questions to help you get a feel for what questions might look like. So here we've got the table gives information about the areas of some farms in France. So we've got area in hectares and we have been given the frequency. The question asks us to draw a histogram to show the information on the grid. So as I mentioned, we are going to need to be able to plot frequency density. So to work this out, what I'm going to do is I'm going to just draw myself an extra column here and also an extra column to the right of the table as well. So I'm going to just do that. There you go. It's not very neat, I do apologise, but it's alright, it will do. So class width, I'm just going to write that as CW. So the class width is the size of the base of the bar that we're going to draw. So it's the difference between these two numbers. So the difference between 20 and 0 is 20. The difference between 20 and 50 is 30, because 50 take away 20 is 30. 100 take away 50 gets me a class width of 50. And finally, the class width here is 200. So again, remember I need to plot the frequency density. So again, just to keep it short and easy, I'm going to put my frequency density in there. So to calculate my frequency density, I need to do my frequency divided by my class width. So I'm going to do 50 divided by 20, which is 2.5. 90 divided by 30, which is 3. 120 divided by 50, which is 2.4. And 160 divided by 200, which is 0.8. Now I've got my frequency densities and my class widths from here. I'm just going to plot it on. So the first one, between 0 and 20, so I need to work out the scale on this x-axis. I've got 10 little squares to go from 0 to 50. That means that each little square here goes up in 5s. So 5, 10, 15, 20. This is where 20 is going to be. And my frequency density is 2.5. So drawing up that line there is 2. Now this is nice and clear. I've got 10 little squares between 2 and 3. So each little square is 0.1. So I can just go up to 2.5 there and draw across. Okay, so my second bar is between 20 and 50. So I know that's 20 because I've just drawn it, and 50 is here. My frequency density is 3. So I'm just going to need to extend this line up, and then the line from 50 goes up to 3 as well. Okay, so my next one is between 50 and 100, and the frequency density for that is 2.4. So I knew that was 2.5, so 0.1 down from that is 2.4. I'm going between 50 and 100, so I'm going to this line here, which is here. And so I remember it's 2.4 this time, not 2.5. And then down to 100. There we go. Okay. And last one, between 100 and 300. So between 100 and 300. My frequency density is 0.8, so my 0.8 on my graph is here, and all the way to 300. That's why I really like my see-through ruler, because I can actually read through it. And there we go. Nice, easy 3 marks, if I can remember that formula that I gave you at the beginning here. Okay, so that's question number 1 done. Question number 2, slightly different. It's tricky, but once we get a feel for the different styles of question, hopefully it will be good. So the histogram shows information about the times taken by a telephone call centre to answering incoming calls. Work out an estimate for the percentage. Now this is really key here. We're not just working out a number, we're working out a percentage of the calls answered in less than 40 seconds. So 40 seconds is up to here. So the first thing I'm going to do is I'm going to work out the total number of calls. And to do that, remember it's the area of each of the bars. So I need to work out what the scale is going up in. So 0, that must be 10, 20, 30, 60, and that's okay. So the area of this bar is going to be 3.1 multiplied by 10 plus 2.2 multiplied by, the difference here now is 20, because between 10 and 30, 30 take away 10 is 20, so my class width here would be 20. Not just because there's 20 in the middle there. Then my next frequency, so the difference between 30 and 60 is 30. My frequency density is 0.9. So it's going to be 0.9 times my difference of 30, or my class width there of 30, plus my frequency density, which is 0.3, multiplied by 60. Okay, I will just draw that in so you can see that there is 30 and that there is 60. That's where I've got those numbers from. So just working that out then, 3.1 times 10, 31, plus 44, plus 27, plus 18. and adding all of that up together gets me a total of 120. So we know that the total number of calls is 120. So now what we need to do is find out the number that are less than 40 seconds. Well, we know that this bar here, that I have just very roughly shaded in pink, represents that 31 there. And we know that this bar here, that I've shaded in green, is represented by that 44. So that's a really nice start. What I then need to do is to work out how many is in that part, because remember that 27 actually is the whole of this bar, not just this blue bit that we need. So now my class width is between 30 and 40, so that's 10, multiplied my frequency density, which was 0.9, so that is 9. So that blue part there represents 9 calls. So the total calls less than 40 seconds is 31 plus 9 plus 44, which is a total of 84. Going back to the question, it asks for the percentage of the calls that are less than 40 seconds. So the percentage is going to be the number of calls less than 40 seconds out of the total number of calls, which was 120, and then multiply that by 100 to get your percentage, and that comes out at a nice round 70%. So that one is slightly harder. It is still 3 marks, but we need to know the different styles of questions. Okay, example number 3. So, the unfinished histogram shows information about the heights of some trees. A key is also shown below. Calculate an estimate for the number of trees with heights in the interval. So interval is like the range between 5 and 10. So in this key, we can see that this amount of squares represents 20 trees. So this amount of squares here in the key basically represents this part in here. So we know that that is represented by 20 trees. We know frequency is the frequency density times the class width. So I know the class width is 2, and what my aim is here is to find out what the frequency density is, so that I can work out what the overall frequency density is here, to work out the frequency density for the rest of my bar chart, because sorry, not bar chart, please forgive me, the histogram, because I need to go up to 10. So actually the formula, I don't know where I write that, the formula that I do want is frequency density is frequency over class width. So my frequency, which was 20, divided by my class width of 2, gets me 10. So I know that this value here must be 10, and then looking at my scale, this is 20, 30, 40, 50. Okay, and looking at this, between 10 and 20, I have got 5 little squares, so it must be going up in 2s. So that's 12, 14, that's 16, and this one here is 32, 34. So an estimate for the number of trees with a height in the interval 5 to 10. So 5 must be in the middle of 4 and 6. Is that okay? I hope so. So 5 is right in the middle. So the difference, or the class width between that there, is going to be 1. And we've got our class width between 10 and 6, so between this number and this number here, the difference between that is going to be 4. So an estimate for the number of trees, that is asking us for a frequency. So I would like the frequency of this orange part, which is going to be 1 times 16. And then I'm going to need to add that to 4 times 34, which is going to be this green part here. So 1 times 16 is 16, and 4 times 34 is 136, and therefore the total is going to be 152. Okay, so part B. There are 75 trees with heights in the interval 10 to 13. Use the information to complete the histogram. So if we say the height is between 10 and up to 13, and including 13, my frequency is 75. I can now work out my frequency density, which is what I need to be able to complete the histogram. So what I'm going to do is I'm just going to find out what the class width is. So the class width is the size, the difference between these two numbers. So 13 take away 10, which is 3. So my frequency density, using my formula that up here, is my frequency, which is 75, over divided by my class width, which is 3. So I get a frequency density of 25. And then I can just draw that in, 20, 22, 24, so it's in the middle. And I need to be careful here because it's between 10 and 13 from the question, and therefore I know that's halfway between 12 and 14. So this is quite a tricky one because it's all in the middle of all in the middle of boxes. So that's 25. The pen's quite thick, so it has gone slightly over. Please make sure that you are using a really nice sharp pencil to get the precise one. I should not have drawn, I got a bit carried away talking to you then, should not have drawn that line there. It only needs to go up to here. So that is the completed bar for the histogram. Okay, 2 more questions to go. So here is another incomplete histogram showing information of heights of a group of children. There are 10 children with heights between 130 and 135 centimetres. So that 130 and that 135 is represented by this part here. So I can work out, again, I'm not given the values of my frequency density, and I'm going to need to work that out. I know frequency density is my frequency over my class width, and in this case I know 10 is my frequency and my class width, the difference between 130 and 135 is 5. 10 divided by 5 is 2. So for this bar, which is the between 130 and 135, this value here must be 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was the 5th one, so that must be 1. 1, 2, 3, 4, 5. That must be 3. There. Okay. How many children had heights between 110 and 130 centimetres? So to work that out, I need to work out the area of that bar, the area of that bar, and the area of that bar. So my blue one is going to be class width of 10 times my frequency density of 1. My green bar, now that is 125, so it's going to be 5, which is my class width here, times 2, which is 10, and then my class width here, which is 5 again, and my frequency density, which is 3. So blue area gets me a frequency of 10, green area gets me also a frequency of 10, and orange area gets me a frequency of 15. The total of that is 35. And the last question for this bit, and then I do have one final question for you. There were 6 children with heights between 135 and 145 centimetres. Show the information on the histogram. So just as we've done in the previous question, we've got height, frequency, class width we know we're going to need to use, and frequency density we are going to calculate. So the height is between 135 and 145. The frequency is 6. The class width is the difference between that, which is 10. 145 minus 135 gets me 10. My frequency density is my frequency divided by my class width. So 6 divided by 10 is 0.6. And then I can just draw that on. Now there are 5 little squares between 0 and 1, and therefore they must go up in 0.2s. The reason I know that is because 1 divided by 5 is 0.2. So 0.6, remember, is the frequency density that I need to plot on. So 0.2, 4, 6, and I'm going to 145, remember. So 145 is in the middle of 140, 150, which is that line there. So I end up with that. There we go. Final question is number 7. I don't know why it's called number 7, but that's just what it is. The incomplete table and histogram show information about the weights of some books. So, okay, so I'm not given a frequency between 0 and 1, but I'm given a bar. I'm given the frequency and the bar between 1 and 2.5, and then I'm not given any more information on the histogram, but I am given the frequencies. So part A says use the information in the histogram to complete the table. So I know this information and I'm going to have to work that out. So let's draw a class width column in. Getting lazy now, I'm not using my ruler for my table. So my class width here is 1, my class width here is 1.5, my class width here is 1.5, and my class width here is 2. Frequency density, hopefully you've all got your formulae in front of you. Frequency density is frequency over class width. So frequency density is my frequency, 36, divided by my class width of 1.5. That gets me, oh, I've lost my piece of paper with all my answers on, here it is. That gets me an answer of 24 for my frequency density. So I know that this value here on my frequency density for this bar must be 24. So just need to work out what that scale is. 10 here, 20 here, 30, 40, 50. Okay. So now I know that what the frequency density is. I know that's 10, 12, 14, 16, 18. That frequency, that frequency density is 18. Forget that there. That frequency density 18, and then to work out frequency, we need to do frequency density times class width. So frequency density times class width, 18 times 1, it just so happens that that does come out as 18. Finally, use the information in the table to complete the histogram. So I am going to need to work out the frequency densities for these two and then draw it onto my histogram. So 57 divided by 1.5 to work out my frequency density. That gets me 38. And nice easy one, 24 divided by 2 is 12. And I now just need to draw these on. So between 2.5 and 4 is a frequency density of 38. So I need to extend that line, and 4 There we go. And 12 up to 6. And there we have it. Lots of different histogram questions. Enjoy your practicing. Good luck, guys.